I want to talk about a tax that every ZK protocol and every DeFi app doing on-chain cryptography pays every single day, and a way to eliminate it. And that tax is EVM compute cost. Ethereum's virtual machine was designed for financial logic, not cryptographic workloads. A Poseidon Ash, for instance, the building block of almost every ZK proof system, cost around 23,000 gas in pure solidity. BLS signature verification is even worse. The usual answer is precompiles. You write a new EIP, you wait for years for approval, and hope your chain supports it. But that's not a solution. That's just a roadmap item. But Polkadot has a better answer available today, and it's called Palette Revive. Palette Revive is a Polkadot runtime model that does something unique. It lets EVM contracts and native Rust contracts coexist on the same chain and call each other. And that's the entire insight this project is built on. And that is the Polkadot Rust Bridge. Here's exactly how it works step by step. On an existing Solidity contract, for instance, it calls an XCM Rust Bridge Poseidon Ash, a simple function, just like calling any other contract. But inside the bridge, two things happen that most EVM developers have never seen. First, the arguments get re-encoded. Ethereum uses ABI encoding. Polkadot uses scaled encoding. Little Endian compact prefixed completely different format. The bridge handles that translation in Solidity in a library called a scale encoder. It also prepends the inc function selector, a 4-byte Blake 2 hash of the function's name, analogous to Solidity's own selection scheme. Second, the encoded call data gets dispatched to the inc contract. There are two parts. The primary demo part uses Palette Revive's key feature, which is every inc contract gets a deterministic EVM address derived from its Polkadot account ID. The bridge does a plain, address.call, a normal EVM low-level call, and the runtime routes it into Rust. The second part wraps the call in a full XCM transact instruction dispatched through the XCM precompile at 0x0401, which is the production cross-chain path. The Rust contract receives the scale encoded cost, runs the computation natively in RISC-V, and returns a scale encoded result. The bridge decodes it back to a Solidity type. From the caller's perspective, they just call a function and they got a number back. The cross-VM translation is completely invincible. Now, here's the real numbers measured live in Parcel Asset Hub. A Poseidon Hashing uses 1,600, 200, 1,620 gas in Rust. And it is 23,000 in Solidity. That's a 14x reduction. BLS verification, for instance, uses 3,077 gas versus the 30,000 plus. That's nearly a 10x. Both contracts are deployed right now on chain. And you can verify the transactions on Block Scout. I want to be upfront about the scope. The math primitives here are demonstrations. Here are the comparisons. Here is deployed on the testnet, and here is local. So we can see the difference between Solidity and calling it from Rust. So the math primitives here are demonstration implementations only. For instance, the Poseidon here uses a 128-bit arithmetic as a structural approximation. Production ZK we use a normal proper BN256 field library plugin. The architecture is the major thing, is the contribution, the pattern, the encoding bridge, and the two dispatch parts, the developer experience, and what this unlocks. Because the encoding and dispatch is fully handled, integrating this into an existing Solidity project is just about 4 simple lines of code. Call the bridge and get your results. Rust does all the work. The full stack, which contains the inc contract, the Solidity bridge, the scale encoder library, all the tests, the 33 plus passing tests, the 4-step deploy script, and our live React benchmark dashboard. Everything is open source and it runs locally in 3 minutes without requiring any wallet. So Polkadot's multi-VM architecture means you do not have to choose between, EVM compatibility and compute efficiency. The Polkadot Rust Bridge is the pattern that connects them. Thank you.